think it would be half sec squared x. I don't know if that's right.
I hope so, if you were looking up the thing. Aha. Where do I have these things? Hang on. I just want to see if I have them to hand. No, I need to find them. We want the formula booklet. That's it. Yep. Okay. Yeah. So any idea how this one works? Tan squared x. Do you want that is the same as?
Oh, there's an identity.
Mm-hmm.
I'm not sure. Is it like sec squared x something?
Yeah, so I can never remember them. So I always just write sine squared x plus cos squared x is identical to 1. So that's the only one I can ever remember. If we want tan, what do we have to do?
Sec squared x plus 1.
I don't know. I just divide everything by cos squared x to get sine over cos tan. And so, what does that give you?
Tan squared x plus 1 is equal to sec squared x.
And so, what's tan squared x equal to?
Sec squared x minus 1.
Yeah, so I never remember if it's plus 1, if it's minus 1, and so I just do that. And what do you get?
That would be tan x,
Mm-hmm.
and then 1 would just be x.
So tan x minus x plus c.
Yeah.
Tan x minus x plus c. So you just always just look up your formulas. I was doing a lesson earlier, and one of them was like the derivative or the integral of tan x, and it was just right there. If it isn't in your list, use an identity to turn it into something that is.
Okay.
Okay, let's try. They're making our lives difficult.
Squared Well, sine squared x plus cos squared x is equal to 1. So sine squared x is equal to 1 minus cos squared x, but that's not there either. But sec is 1 over cos.
So sec squared x is 1 over cos. Cosec x. Let's think. Sine squared x 1 minus cos squared x. I don't know. Oh, there you go. Okay, we have to use double angle formulae.
So cos 2x is equal to 1 minus 2 sine squared x. So sine squared x is equal to 1 minus cos 2x over 2. Isn't it cos 2x is 1 minus 2 sine squared x?
I'm sure you're right.
I'm not sure, but I think it is.
Minus 2. You know more about it than I do. So that's going to be that. So it'll be okay.
I got half x minus a quarter sine 2x plus c.
Half x minus a quarter sine 2x plus c. That's what you got, is it?
Yeah. Oh wait, isn't it a definite, so there's no plus c?
Yeah, so you don't need the plus c. That'll just be 0.
Yeah. It's just really long.
And so just so you're aware, like just because you're working it out, I'm working it out. Usually I wouldn't bother. They told me that it's going to be, they told me what the answer's going to be, and so that's just what I go with.
Oh.
You know what I mean?
Yeah, but isn't it a show that so you actually do have to work it out?
Well, I have shown it. So if you look at what I did, so I subbed in pi over 8.
Yeah.
Big brackets around everything. Then take away big brackets around everything, what you get when you sub in pi over 12. And then I put it all in my calculator, and pinky promise, this is what it showed me.
Okay. I'm doing it.
You're a careful girl, so you were checking your answer. Nothing wrong with that.
Mine's giving me a decimal and not a.
So what you might need to do is do like them separately to get an exact thing. So that's what I'm thinking. You would have to do all the pi ones. You'd have to probably do 1, 2, 3, 4 things separately, and then do the pi things. that end up with pi.
I don't need. Hold on. I don't think I need the calculator. I can just do it.
Oh yeah, that's a good point. Yeah, you might need a calculator for the.
I probably just need it for the pi over 16 minus pi over 24, but I wouldn't actually need it. Yeah, okay, I got it now. I got pi over 48 plus 1 minus root over 8. Yeah, the answer.
Great. Yeah, and yeah. So looking at the exam. So this is just the thing. I believe that you don't need to do any more than that. So there is no intermediate step in between there. Any questions there? Okay, so this one actually comes up a lot. Cos 2x.
Yeah, I think
So that one is 1 minus 2 sine squared x, and it's also something else.
There's like 3 for cos 2x.
Yeah, I think one is something like cos squared x minus sine squared x or something. And then the other is 2 cos squared x minus 1 or something plus 1. I never remember.
I'm not really sure how to do it, but I know when you have like the derivative of a function over the function, it's just ln of the function. But I don't know how to make this like that.
I have a suspicion. What if it said... no, I better do it. Sine 3x, that is the same as sine x plus 2x.
Yeah.
And so that's a double angle. That's a compound angle formula.
Oh, okay. Same for cos.
Mm-hmm. I hope to God there isn't a quicker way of doing this.
Oh, then you have to do like expand it.
Yeah.
I don't know how to do it. I have a formula book somewhere. I just have to find it.
So I wrote out the sine one.
Yeah. Wait, but then you have to integrate that whole thing.
Sure do.
How?
Well, we'll cross that bridge when we die on it.
Wait, there's one that says that if you have like the derivative multiplied by the function to the power of n. So will it work if the function is to the power of 1?
So go on. What are you thinking?
Because if you do the derivative of cos 3x is just 1/3 sine 3x plus c. So if you make that if you put 3 like outside the integration sign, then you can put 1/3 inside. So then you'd have 1/3 sine 3x cos 3x. Yeah, like that. And then you can just integrate it, and then you would just get cos 3x the whole squared over 2 plus c, and then times the whole thing by 3.
And you get what, sorry?
So you would get, the final answer would be 3 cos 3x squared, or cos squared 3x
3x.
over 2 plus.
Maybe.
Oh,
That's cheating.
formula again.
That is cheating. Say it's double angle. So sine 2a.
Letters.
Cos a. And so instead of writing it as x plus 2x.
So then you just have half of sine 6x. Right? To integrate, which would then be half. You could just take half out. And then minus 1/6 cos 6x plus c, which should then give you minus 1/12 cos 6x plus c. No, it's not plus 6x, it's cos 6x, yeah.
It's 112 cos 6x. Cos 6x plus c. Okay, wow. So we have to, if we see the same thing twice, sine something, cos something. That is double angle formula in this, guys. Okay, how about question B?
I think you'd expand that.
I think so as well.
Because you would have like sec squared x, and then. So if you expand that, you'd have sec squared x plus 2 tan x sec x plus tan squared x. So sec squared x just integrates to that one. But
sorry.
Yeah. So that's just tan x. I think it's just tan x. And then 2 tan x sec x. So I've seen that before, but I don't know where.
I think we might have to do by parts for that one.
Oh. Okay. Don't really know how to do that.
Wait, what's the derivative of tan squared x?
I have no idea.
Tan squared x is the same as sec squared x minus 1, so that will work out. Okay, so doing by parts for that one in the middle should be okay. 2 tan x sec x. So u is equal to tan x. dv by dx is equal to sec x. I need to get my derivative thing. Okay. How do we do this?
I don't know how to do this.
You don't know by parts.
No.
So with differentiation, product rule, you get uv, and then you get du dx dv dx. So get du dx.
Du by dx is sec squared x, I think. Yeah.
Yep. And
you integrate that one to get v.
Yeah.
Which is, how do you integrate sec x?
Wow.
Oh, there, yeah. Ln sec x plus tan x.
Oh, I don't like the look of this. Hold on. Okay. And then we put it into our by parts formula.
Okay, so tan x minus sec x dx is equal to uv. This is not looking nice.
No, it's going to get more difficult because we now have, instead of sec x plus tan x, we have ln. And so we could try swapping them around. We could let u be equal to
Sec x.
Yeah.
So v would be ln sec x. And then du by dx would be sec x tan x.
Sec x tan x.
Sec x tan x.
U times v.
Isn't it u times dv over dx?
U times v first.
But you have to do that first. Oh. Sec x ln sec x.
So that's like du. Nope. That's going to just get more complicated, isn't it? The derivative of ln.
Yeah.
But oh, why? Okay. They expanded it. Sec squared x.
Oh.
Yeah, that's fine. 2 sec squared x plus 2 sec x minus 1, sure. So that
They just integrate that.
Whoa, hold on. But how did they integrate to sec x tan x? Oh, hang on. They used some magic again. They noticed that in the differentiation one.
Oh, sec x tan x and sec x. Okay. Yeah, that makes sense. I thought I'd seen it before, but I didn't know where.
There you go. So sec squared x. Yep. That was tan x. Or
And
you
then
could
2 sec x. Then next tan x sec x just goes to 2 sec x, I think.
Yeah.
And then
this is the same as sec squared x minus 1.
Yeah. So that's plus sec squared x minus 1. So when you integrate sec squared x, you get tan x plus x. So you just have 2 tan x.
Yeah.
2 sec x plus x.
I believe it's minus x at the end, because it was minus 1.
Oh, okay.
Tan x plus 2 sec.
So minus x plus c.
Minus x plus c. Yeah, if we go back to where I saw tan. Yes, minus x. Okay, well, at least we know what we're doing with by parts. 2 tan x plus 2 sec x minus x plus c. There you go. Okay, Exam question time.
Sine squared x again. So sine squared x is equal to 1 minus cos squared x. Wait, no. Yeah, that's right.
That's true. Does it help us?
No, cos 2x is equal to 1 minus 2 sine squared x. There we go.
This one.
So sine squared x is equal to 1 minus cos 2x over 2.
Mm-hmm.
And then
I just write it as a half minus a half cos 2x.
oh, do you have to write? You don't have to write.
Just makes it easier to integrate.
But surely you can just take out the half.
Yep. So most students kind of they have more difficulty taking out the half. I find it easier, but they just forget to bring it back in.
And it's easier to do it that way as well. So x and then cos 2x is just half sine 2x. So that would give you half x minus a quarter sine 2x. In brackets with the limits pi over 4. So you don't have to actually like solve it, or do you have to?
No. So that's that, and then that.
Like if you write it out like that, you don't need to do anything else.
And then just 2 plus pi all over 8. Yeah. And I believe it would be like 1 mark, 2 mark, 3 mark, 4 mark, something like that.
Wait, why is there? Oh.
So you left the half in, but you initially said you're going to take it out. So I just.
No, I did take it out, but then in like the second step, I just like when you have the full like the integration in the square brackets, I just multiplied everything by half again.
Okay. You can do it at any point, yeah.
Otherwise, I will forget about it or like make a mistake or something.
Yeah, I just stopped taking it out. I find it's just easier just leave it in and just deal with it. Any questions there? I think the big thing is the cos 2x equals 1 minus 2 sine squared x. Yeah, so you can see there's no intermediate step.
Yeah, okay. That makes sense. I mean, they're kind of full, but I think intermediate step.
How about this one?
Oh, this is another cos 2x is equal to something.
Sure is.
I don't know what it is equal to.
I was hoping you would know. It's probably
this. I can look it up though.
That's probably something like 2 cos squared x plus 1 or something.
I think that's right. But
let's see if you have it there.
It's 2 cos squared x minus 1.
Minus 1.
It can also be cos squared x minus sine squared x.
So which one will we go with?
2 cos squared x minus 1.
I greatly prefer that one too.
So that would just be cos 2x plus 1 over 2. It's equal to cos squared x. So half. So a quarter sine 2x plus half x.
X plus half x. Yeah. And then you just
Yeah, and then you just
sub in the things and yeah. Any questions here?
no.
Okay, so we've got the handle on the sine squared, cos squared. Okay, let's see. So we've got two things here.
No, the test seems like proof.
Which one do you like the look of?
Any's fine.
Right.
Oh, that one that says sine 3x cos 2x is the same as that one that was like similar. Sine 2a 2 sine a cos a, I think. But they're not the same.
Double angle formulae. They're not the same.
Oh wait, it says sine 5x plus sine x is equal to 2 sine 3x cos 2x. So you can just replace sine 3x cos 2x by sine 5x plus sine x over 2.
You can replace it with what, sorry?
Sine 5x plus sine x over 2. But I'm taking the half out. It says in the question above.
Yeah, yeah.
So that's equal to
0 marks. 4-mark question. Using the double angle formulae. So you must actually.
Oh, do you actually want to do that? Oh, I thought we were just doing the integration part.
I don't actually want to do it. If you're
Okay.
happy with it, I'm happy with it.
Yeah.
So then how do we do? Oh yeah, so part B.
Yeah, given these formula double angles, so it's just okay. I know how to use them.
Okay, and sine 3x cos x, so that is a half sine 5x plus a half sine x.
So I got minus 1/10 cos 5x minus half cos x plus c.
Looks correct to me. Minus 1/10 cos 5x minus a half cos x plus c. Is this one worth doing?
No idea how to do tan squared 2x, so
You'll figure it out.
wait, tan squared x is equal to sec squared x minus 1.
Mm-hmm.
So wouldn't tan squared 2x, wait, would that just be sec squared 2x minus 1, or is that wrong?
Hang on, I need to. Where's my thing? I'll take both of them just in case. No. Yep. And what was the question, sorry?
Would tan squared 2x be equal to sec squared 2x minus 1, or is that wrong?
That's correct.
Oh, it's right, okay. Question sec squared 2x minus 1, which would give you half tan 2x minus x, and then limits and stuff.
And if you're happy, oh yeah, hold on. That's square brackets. I think you did the hard part of that one. You can keep going if you want, or we can move on. I don't mind.
Yeah, I can move on. I can solve it.
Okay, so a half tan 2x minus x.
I actually do understand integration now, so it's like getting better.
A half tan 2x minus x. Yeah, and then just chuck in all stuff. Let's see. So how would you set... Oh, something's wrong here. Yeah. Are either of these worth doing?
Questions.
Sorry?
Oh, I didn't realize there were two different questions, and I got confused because they have the same number.
Yeah, I just take them from the exam things, two different books. So this one, I think you'll be fine for 6 on the top.
Maybe.
All right. How would you do question B?
X. This is 3 sin x, 6x cos x. So I'm not sure how to do that.
How do you go from 2 to 3?
Divide by 1.5.
And dividing by 1.5 is the same as?
Multiplying by 2/3.
Yep. Keep change flip.
Yeah.
And so?
Oh, so you just do... Wait, what? Oh, 3 times 2/3 gives you 2. So you can just put 2/3 outside of the... Yeah, there. And then you can just do... But that wouldn't be right. No, wouldn't you have to put 3/2 outside and then put 2 on the inside? Because then when you multiply it, you still get 3.
That's what we would need. Hold on. Let's take a look at this one. So we want to get 3.
No,
so
you want...
divide both sides by 2.
Wouldn't you want 2, not 3?
Hang on. So 3/2 sine 7x plus sine 5x. So that's equal to 3 sine 6x cos x. Is that right? You would divide both sides by 2 and then times both sides by 3. Yes. And so it would be 3/2 on the outside.
Yeah, and then wouldn't you have... Yeah, that on the inside. And then you just have to integrate it after that.
And yeah, and it's actually pretty easy to integrate, just sine.
Yeah, it's just minus 1/7 cos 7x minus 1/5 sine 5x plus c.
Cos, I believe.
Yeah, sorry, that's maybe cos.
So that's going to be 3.
So that would be
10.
minus 3/14 cos 7x minus 10.
14 minus 3/10. That's part A.
Part B.
Oops. I have part A for one question and part B for the other. Well. Oh, there we go. Minus 3/14 minus 3/10. Good. Let's see this one.
It's 4x.
Okay.
Oh, I know how to do this one. Cos 4x is equal to cos squared x times cos squared x. So then you just replace one of the cos squared x by 1 minus sine squared x. And then you have cos squared x minus cos squared x sine squared x, I think. But I don't know what else to do.
U squared x, sine squared x. What kind of wild goose chase have you got me on here? cos 4x, cos 2x. Cos 2x is going to be the same as something.
Oh, wants to show that cos to the 4x is equal to that and not. Oh, I thought it meant like the integration of that is equal to that. Never mind. It's probably wrong.
So well, this is true. So we know that cos 2x is 1 minus 2 sine squared x.
But we don't have that.
We also know that cos 2x is identical to
You could.
2 cos squared x minus 1. So you could. Yes, or go on?
No, I don't know.
So this cos squared x here. So cos squared x. We know that that's identical to. What is it? A half minus a half. Or is it? Sorry, plus is it? Plus a half cos 2x.
Why would, oh yeah.
So this one we can replace with a half plus a half cos 2x. So I'm seeing a half cos 2x there. This thing here minus, well, we just said cos squared x is a half plus a half cos 2x. And sine squared x.
You could just do that as 1 minus cos squared x. So you can just do 1 minus half plus half cos 2x.
I like that. You have to end up with cos 4x though.
That is true. Oh yeah, because when you have you should have. Oh, I don't know actually.
Let's see. Is there a
Cos 2x yeah, you wouldn't even have half cos 2x because it looks like they're going to cancel out.
No, well, I reckon. But cos 4x might be just cos 2 times 2x.
I don't know how to do this. It looks really complicated.
A half cos 2x plus 1 all squared. Wait, what? Oh, there we go. So that's a half cos 2x plus 1 all squared. So they did this bit.
Yeah, that should be cos 2x plus 1 divided by 2 for cos squared x. So I don't think that half plus half cos 2x is right. Yeah, it is. Never mind.
It's all true, but I think so they just directly
just wrote it differently and then I got confused.
So cos squared x times cos squared x. But they said that that is the same as yes. So our cos squared x. So they wrote it. Yeah, they did it.
I think it's the same.
Yeah, it's the same thing. So they just cos 2x.
But I like their way more of writing that because I don't like that half plus
fractions. So,
yeah.
Okay, so you expand these two brackets.
So you just expand it out after that, I think.
Yeah. And then they
expand it. Okay.
Right, you just expand it,
but where did the half come from?
That's your question?
No, the second one. Like
they just.
Where did that come from?
They cos squared 2x.
How did that become half cos 4x plus 1?
Cos squared 2x is the same thing as cos 2x squared.
Okay.
And we just had, we said cos 2x is the same as 2 cos squared x minus 1.
Okay. Oh, okay. Okay.
And so minus 1, 2 cos squared x minus 1. So it's just even more expanding.
Oh my God. How is this only 4 marks? This is such a hard question.
I think it's because they just used their own little algebra magic and just said, these, like that's the final thing. That's so they give you this in the question.
Yeah, but that's not helpful.
And they said, once you convert cos squared 2x into that, they'll just, they'll get no marks for expanding the whole thing. So it's just lots and lots of expanding brackets. Well, any questions there?
No, not really.
Okay, trig identities.
I mean, I didn't know double angle formula counts as trig identities.
Yep.
I thought it was just like a different thing. But yeah, I know how to use them as long as I learn the formulas. That's okay.
So trig is pretty huge, and identities are just what is it? Yeah. Anything where it's the same thing, just written a different way. Mm-hmm. How are you for reverse chain rule?
Not really good.
You cheek this man. Okay, hang on. Let's recap.
Wait, that's just ln like of the function, but I don't know where the k comes from.
It is times by.
Oh, constant, right?
Yeah.
Is that constant? So you can just take it out.
Yeah.
So that first one is just ln x squared plus 1.
Yeah. Hang on. You cheek this man every day. So, what was the first one?
Ln modulus x squared plus 1 plus c. Yeah.
Mod x squared 1 plus c. Okay. So you're better at that than you realize. Sick. Okay. So, yes.
Fine.
I think I'll do it this way. Okay, so big picture. You're given the these things, these formulae. So you try to change it into one of these. If they give you tan squared x, turn it into sec squared x minus 1.
Mm-hmm.
Tan x, that's okay. Cot x, that's okay. Cosec, sec. The other possibility regarding those things is this. If you have something, you can look at your differentiation.
Yeah.
And work in reverse. So sec x tan x, and then you say, oh, that's integral of that would be sec x. Sine squared x. How do we integrate it?
Cos 2x.
What if it was cos squared x?
The other one. Yeah, it's 2x. 2 cos squared x minus 1.
Yeah. And the other possibility is the other cos 2x one that might come up.
Yeah. So that's like cos squared x minus sine squared x or something.
Yeah. So if they asked you to integrate that, you would just change it into cos 2x.
Mm-hmm.
And there are other possibilities, like if they wanted sine squared 2x.
Mm-hmm.
Well, no. Let's just stick with what they're giving us. So sine 3x, cos 3x. So I was thinking it would be this thing, but it was actually the same as sine
2a.
Yes, sine 2a. Okay. No, sine 3a.
Yeah.
Sine 3a.
3a.
Yeah. Right. Basically, a is 3x in this case.
Yeah.
And so it is
sine 6x is equal to sine 3x cos 3x. Wait, no, sine 6x.
You had to half both sides first.
Yeah.
Okay, so that's the other way. So same thing twice. This one, we had to look up. No, it's fine. Sine squared x, cos squared x. These ones is just double angle formula mostly.
Yeah.
But it's pretty good, and these seem to come up a lot where they actually give you part A and part B. So these are the ones in the examples. The example ones, they kind of just left you on your own, and if you didn't know how to do it, then you just got 0 marks. Whereas in the exam question ones, I notice that they give you part A and part B, where part A doesn't involve integration, but if you don't know how to do part A at all, if you forget, then part B, you can still piece it together using part A, because they kind of tell you what it is. Tan squared 2x is the same as sec squared 2x minus 1. That's all right. So that's the one, yeah. So this one was just lots and lots of expanding brackets.
Yeah.
Other than that, it's okay. So it's a lot of work for what that one is. Okay. We have some time for reverse chain rule. How do we do second one? Hang on. What is reverse chain rule? So if the top is the derivative of the bottom, then you can just do it. Okay.
The derivative of 3 plus 2 sine x, well, the 3 would just go. And then how do 2 sine x? Oh, that would just be 2 cos x. But you only have cos x on the top. So you have to multiply by 2, and then you have to put half outside the integration. Now it's the same. So now you can just do half ln 3 plus 2 sine x in modulus, plus c.
Plus c. A half ln 3 plus 2 sine x plus a. Great. To integrate of this, try ln fx and different. That's what we just did.
3 cos x sine squared x.
Ooh, I did not look close enough. Hold on. To integrate expressions of this form.
A similar method with functions of the form k x to the n.
Ooh, you can you?
Yeah. It
yes.
Gives you the function to the power of n plus 1 over n plus 1 plus c.
Okay, let's try this.
So when you differentiate sine squared x, what would you get?
When you differentiate sine squared x.
How do you differentiate sine squared x?
So I'm just guessing, but sine squared. No, hang on. We could say. I don't know if it'll be this one. Cos 2x is 1 minus 2 sine squared x.
Yeah. So sine squared x is 1 minus cos 2x over 2. So to differentiate that, you would just have to do 2 sine 2x times a half, so you just have sine 2x. Yeah. So I don't know how to do it with cos 2x and cos x. Okay. I don't know how to do it.
I would have just used by parts, but I think they have some sneaky trick. Sine cubed x. 3 sine.
I want to know how. If you know how to do sine cubed x, then why can't you just do sine squared x straight away? So, why would you have to consider y is sine cubed x when you could just do what sine squared x is, which would just that'd be easier.
So y equals sine cubed x, dy by dx is equal to this. How did they get that though? So the original thing, so it's just sine cubed x. That's not given to us or anything though, is it?
No. And I don't understand how just because they're equal means that it integrates to sine cubed x. Like, I don't understand. Because,
Differentiation and integration are the reverse.
yeah, I know that, but shouldn't it be like the derivative and the function? Because
So,
there's a function there. There's only the derivative is 3 cos x sine squared x. Oh,
so
I'm so dumb. Okay, I understand.
yeah.
I thought it's because it talked about reverse chain rule, and that one has nothing to do with reverse chain rule. So I got confused because I'm like, there's no function, blah blah. Okay, I know how to do the second one.
Go on.
So you need 2x. So you have to put half outside of the integration sign. Yeah, like that. And then you have 2x, x squared plus 5 cubed. And then the integration of that is just x squared plus 5 to the power of 4 over 4 plus c.
1/8. What did we forget? X squared plus 5 to the 4 plus c.
Wait, don't you not have to do times? Oh, you have to do times the half from out.
That's what we forgot.
Yeah.
Okay.
Because when it's in this form, you don't need to multiply it by the derivative of like the actual function.
So this one took care of itself, but yeah, we had to actually.
Yeah, like just the constant.
Let's see. That was what we just did, I believe.
2. Okay, well, 2 and then cot x. What does cot x differentiate to? It tells you, I swear. Oh, minus cosec squared x. There we go. So you need a minus. So you could just put a minus in and then take a minus out.
Yeah, you could do that.
Yeah, I think that's the easiest way of doing it. But it's also 2 plus cot x cubed, so I don't know how to do that.
So cosec squared x.
I don't know how to do it when it's like cubed and in a fraction like this.
Same as previous one, I believe.
Because I only know like how to do it when if there's a power, it has to be multiplied by the derivative. But this isn't a fraction, so I'm a bit confused as to how to do it.
Let's see, 2 plus cot x.
Would you have to expand it and then?
No way we expand this one. That'd be easy.
Is that integration by substitution or not?
No, I don't think so.
I think it is. Wait, no, it's not. Never mind. They just differentiated something. They did something.
So they did some more of their magic, where they said, "Why is this?" And so when you differentiate it, you get that. And so working in reverse, integrating that must get you this.
That's really confusing.
So they said.
But like, how do you know that that's what it's going to give you? Do you just guess?
I think it's because this one is to the minus 3. And then you consider, okay, what would it be to the minus 2?
Minus 2. Oh, that makes sense.
Because you have to take one away.
Minus 2 there, yeah.
So minus 2.
You just guess basically and differentiate it. And then you know what the integral would be.
And what's the derivative of cot x?
Minus cosec squared x.
Minus cosec squared x.
That would be 2 cosec squared x, 2 plus cot x, so minus 3.
Yes. And so then you can use that to work in reverse.
How?
You and your how.
You already have You just need 2 cos x squared x. So it has to be half 2 plus cot x to the power of minus 2. Because, yeah, that's right.
I have 2 plus cot x minus 2 plus c. Yep. Yeah, how was that for you, Amogha?
The second part was like a bit hard. The reverse chain rule.
Good. Any topic in particular you want to do next time?
Is there anything after integration by parts? Like, is there more integration after that?
So integration is just a sprawling behemoth. Yeah, there's trapezium rule.
Oh, isn't okay. I want to do integration by parts though, because I'm going to learn it this week.
Okay. Any questions for me in general?
No.
All right. Well done, Amogha. You did great. I look forward to talking to you again next week.
Mm.
Have a good week. Goodbye.